Okay, we're back. Found the typo in my notes, 0.024. Okay, good. Everything, it was just, this is supposed to be a plus sign, not a minus sign, but all my calculations were correct.
Can you scare us, Daddy?
Can I scare you? Okay. Rawr! So that was my daughter requesting an official scare. She has been scared. Okay. Okay, so next it's asking for the damp natural frequency, okay? And the damped frequency, oh, so it's asking for the damp frequency. So sorry, it's asking for the natural frequency, and that's related to the damp frequency by 1 minus zeta squared, okay? So we could rearrange that and say that omega n is equal to omega d over 1 minus z squared. Okay. Which is equal to 1.20 divided by the square root of 1 minus 0.204 squared, which is equal to 1.23 radians per second. Okay, so notice that our damp ratio is large enough to impact the natural frequency, or really the damp ratio isn't large enough to impact the damp frequency, but it's not too large. Okay, and then we can go ahead and box that like good citizens. Okay, so the next thing it's asking for is the effective mass. Okay, and our effective mass we can get by knowing that omega n equals square root of k over m. Okay. Now let's say in this case we were given k, so the effective mass was pretty easy to get to. But let's say we were asked we were given mass and not the spring constant. Well, then we would just rearrange things. But in this case, so omega n squared is equal to k over m. And then m is equal to k over omega n squared. So m is equal to k, which is 33, divided by 1.23 squared, when that gives us 22 kilograms. Okay, equals m. Okay, so that's our mass. Effective dampening rate, okay, we can get that because we know that the damping coefficient or damping ratio is equal to C divided by the square root of 2 km. And there are other versions of this that all equate to the same thing. And that tells us that C is equal to 2 zeta the square root of km, which is equal to 2 times 0.204 times the square root of 33 times 22, and C becomes 11 kilogram seconds per seconds. Okay, so now we're zooming right along. Now it's asking for, now it's asking for the phase. Okay, so this distance right here, where x is equal to 0, that means that sine of omega, let's make that line a little thinner. Okay. That occurs when sine of omega dt plus phi naught is equal to 0. And that would occur at either omega dt plus phi naught is equal to 0, or if it's equal to pi. So let's just assume it's 0 because that makes our lives a little bit easier. And that means that t phi is equal to, we'll call that t phi, is equal to negative phi naught over omega d. Okay? So t phi is equal to negative phi naught over omega d t. So that ends up being negative 0.896 divided by, now omega d, this is one you got to pay attention to. We want We want this value, not that one. Okay, make sure you pull out omega d, not, and that's, sorry, there's no t here. That's just omega d. And then there's nothing in there. Okay. And this becomes 1.08 radians per second. Hold on a second. I rearranged things. I solved for the wrong thing here. Rookie mistake. Okay, so we had T phi is equal to phi naught over omega d, and we wanted to actually get phi naught, so that tells us that phi naught is equal to negative T naught times omega d. Made my life harder for no reason other than life should be harder. That equals negative 0.8 896 times, and omega d was 1.20. Okay, and then that equals phi naught equal to 1.08 radians. Okay, there we go. Now what we're looking for is initial position, and luckily initial position is coming right from the graph. So x naught is equal to 5.0 meters. That was nice and easy. Now it's interested in velocity, okay? And there's a lot of different initial velocities, a lot of different ways to get initial velocity, okay? There's really, let's talk about the two different equations we could use, because different ones have different impacts, okay? It's embedded in the amplitude, where amplitude is equal to V naught. Let's make that a little bigger so we can all read it. V naught plus omega n zeta x naught squared plus x naught omega r squared, omega n squared divided by omega d squared. Okay, so there's a V naught right here that we can potentially use, and then it's also embedded in tangent phi naught is equal to x naught omega d over V naught plus omega n zeta x naught. Okay, so in our particular, and there's our V naught right there. In our particular case, we could use this equation right here, because we know x naught omega d zeta omega n and phi. However, that only works, that process only works if x naught does not equal 0. If x naught equals 0, you end up with tan phi of 0, tan of 0 is equal to 0. So there's no real information in there, okay? In that case, let's hypothetically say that x naught didn't equal 0. How would we get V naught? Well, what we would do is we'd first calculate A. And now I know what you're saying. But that's a Hildreth. A requires both V naught and x naught. How are we going to get A? Well, my young scribes. Sorry, I was watching Onward with my daughter earlier today. We also have an A right up here. So what you could do is say x of t equals 0, which is in this case is equal to x naught, is equal to A e to the 0 times sine of 0 plus phi naught. That should be a naught right up there. Okay, and then you plug in these particular values. 5 is equal to A sine of whatever phi naught was, 1.08, and then solve for A, okay, and then go from there. So practice that. Make sure you practice it, because it sounds like the type of thing I would test you on, okay? Not guaranteed that's what I'm going to do, but it sounds like the type of thing I would test you on, because I want to test that you're listening to me when I've given you various lectures saying I might do that, okay? Okay, but anyway, we were looking, in this particular case, I'll show you the other way, we have phi naught, so we know that tangent of phi naught is equal to x naught omega d over v naught plus omega n zeta x naught. And that's going to tell us that v naught plus omega n zeta x naught is equal to x naught omega d over tangent phi naught. And then so v naught is equal to x naught omega d over tangent phi naught minus omega n zeta x naught. Okay, and if we plug our values in, we have 5 times 1.20 divided by tangent of 1.08 minus 1.23 times, let me pull up my, let's see, zeta was 0.204, right? Yep, 0.204 times 5. So V naught ends up being 1.99 meters per second. And if there wasn't for rounding errors, it'd come out to a nice 2, okay? And then all that's left is A is equal to V naught plus omega n zeta x naught squared plus x naught omega d squared all over omega d, which is equal to, let's put our numbers in, 1.99 plus 1.23 times 0.204 times, oops, how big is it? Times 5 plus 5 times, and this right here is squared, times 1.2, square that over 1.2 squared, and we end up with A is equal to 5.68 meters. Okay, and I think I left off some units. Nope, I forgot to block some things though. Okay, so that's how we do a problem. Please practice that, and I'll record another lecture to make sure we're going through a whole problem with I'm gonna do essentially quiz 6 next. Okay, thank you, and I'll see you online soon.